Hi, my name is Hamad Khan and I am the Data Management Librarian at UTA Libraries. I want to thank your professor for giving me the opportunity today to present and introduce R and R Commander to you all. If you are looking at this title slide and saying R Commander is misspelled, that is not true. That is actually what you type into R console in order to open R Commander. So I just wanted you guys to kind of get used to seeing it that way and be prepared to see that and type that as we move forward. Alright, so the first thing I want to start by saying is that R and R Commander are two different things. They both belong to each other and can do the same exact things but in different ways. Think of a car. You drive it. But the way you drive it depends on whether you are using a manual gear car or an automatic gear car. Either way, that car will get you to the same destination. The same comparison can be made with R and R Commander. However, in order to use R Commander, you must have R downloaded and open. So you cannot have R Commander if you do not have R. R Commander is included within R. R is essentially a programming language that uses command line prompts, which requires the user to have programming or coding knowledge, also known as knowledge for this software as R language. While R Commander does not require that you know R language, it just requires you to know how to navigate drop-down menus as it uses a graphical user interface, or what some people refer to as a GUI, and that's GUI, and it stands for Graphical User Interface. Specifically, it uses menus and dialog boxes to avoid having to type programming code. R is essentially a language for statistical computing. That language is R command prompts or codes that return results. R is free and open source software, so there are no fees and subscriptions, which is why it is heavily used in the research community. It is also interoperable and is supported on many different operating systems such as Windows, Mac, and Linux. Mainly R is used for its statistical analysis. And we all know data is at the center for any type of statistical analysis. You will mostly be analyzing your data in one of the following softwares. Now, this is a comparison of the most popular data analytical tools and softwares out there. There are, of course, numerous others data analytical software, but these are the most used. I know people working on qualitative data will bring up NVivo, but still, when we talk about data analysis, majority of researchers are either using Stata, SPSS, SAS, or R. What I really want to point out is that R is capable of reading data from most formats, including files created in other statistical packages. Whether the data was prepared using Excel, SAS, Stata, SPSS, or others, R can read and load that data into memory. But let's discuss the file types of R. So the different file types that you can save within R. So R script is simply a text file containing almost all of the same commands that you would enter on the command line of R. R Markdown document is basically written in Markdown, which is an easy to write plain text format and contains chunks of embedded R code. RSweave is a function in the statistical programming language R that enables integration of R code into LaTeX. The purpose is to create dynamic reports that can be updated automatically if data or analysis change. .rds file, which contains a single R object and can be created using save RDS and loaded using read RDS command prompt. And .r data, a file containing one or more R objects or workspaces, can be created using save and then parentheses command prompt and loaded using the load command prompt. So what are the advantages of R? Well, it's an alternative to fee/subscription-based traditional statistical packages such as SPSS, SAS, and Stata. It's open source programming language and it's free to use. It's interoperable. You can load data from SPSS, SAS, Stata, and many other applications into R. Usually, if you're using SPSS and SAS, sometimes you aren't able to download other applications' data, which is why R really is interoperable and you can use it with many different software types. R has over 15,000 packages that are available. Packages are a collection of functions and sample data made available within the console. So a package includes R functions, data example, help files, namespace, and description. So the disadvantages to R is that it's command, not menu driven, which is a major hurdle for many new R users. It's a complicated language. It's hard to memorize those commands. You can think of it trying to memorize codes, and it's really difficult, especially when you start out. It wasn't developed by a company for profit, so most R packages are contributed by users. So maintenance and updates are not managed as well as commercial software. R was designed to use only a single thread processor, not multi-threading. Now, you don't have to really know this, but multi-threading helps do parallel computing efficiently, meaning R is CPU limited. It runs on a single thread on the CPU. It does not matter if you install R on a powerful server with 64 CPU cores. R will only use one of them. So this is related to your operating system and how R uses your RAM and CPU to process data. Big data projects may run into hurdles as using a single thread could be difficult. Think of multi-threading as multitasking, which refers to having multiple programs, processes, tasks, threads running at the same time. R at times struggles to do this even as a single thread if you're using big data. Alright, so once R is running, simply loading the R Commander package by typing in the command library, parentheses, quotation, R, capital, and then lowercase cmdr, quotation, and then close parentheses. Another word of advice, R case sensitive, so if you do all lowercase for R Commander, it will not open up R Commander. So you have to really pay attention what you're typing in the syntax. So that's one of like the disadvantages, I think. So you can easily mistype something. It'll just give you an error and you can just go on to the next line and type again and type it in correctly and it'll open it up. But just be careful about your upper and lower case because it really does affect whether or not packages open in R. So R Commander is, like I said, included in the R console as a package, and you can open it using the following command library and then just follow what's on this slide. So R is a command-driven system and new users often find learning R challenging. By providing a point-and-click interface to R, the R Commander allows users to focus on statistical methods rather than on remembering and formulating R commands. Here on the slide, you'll just see why GUIs are good for avoiding syntax and typing errors, like I mentioned in the previous slide, that you have to really watch your upper and lower case and your spelling in order to get anything to work in R console. But using R Commander, which is a GUI, you don't have to worry about those typing errors. The potential drawback to a GUI is having to drill one's way through successive layers of menus and dialog boxes. For me, going through menus and dialog boxes is an issue, but sometimes remembering a command prompt in R console is more difficult. So here you just have to kind of like search and navigate, which I think is pretty easy for most users. Intention to keep things simple and basic. R based on tens of thousands of functions, which are commands, are grouped into many packages. And I think that's why sometimes the GUI might be a little bit easier to use and to search. So one of the first things in order to start analyzing your data is to make sure your data is clean and ready to be imported. If you can't import it, how can you analyze it? Most people use Excel to organize their data, and this is considered tab delimited text file where you have organized your variables into a spreadsheet. You will make your life a lot easier if you use Excel and save the files as CSV, which is comma separate value files. These are the easiest files for R to read and work with. In fact, other statistical tools like SPSS also use CSV files. Usually when you import a data set in R, you read it in a data frame. This is assuming your data is in a table format. And again, I suggest that you use an Excel sheet to really organize and clean your data because it's so interoperable with so many different data analytical tools. And it's also a lot easier to clean than to clean it in a program like R. R is really not friendly to cleaning up data sets or entering new data, especially, or new variables that might come up. So I would actually just do everything in an Excel sheet and then just import it into R to do my analysis. Remember to fill in any empty fields, like for example in your spreadsheet. If you have missing values, just put, with no measurement, just put NA. If you have small values, you can enter 0, but like it's best not to leave that space empty. Don't leave the fields empty because it's just easier when you go in to do your data analysis in R. So one of the first steps of analysis is exploration. Usually the first step of a data analysis is graphical data exploration. The most important aim is to get an overview of the data set. Where is data centered? How is the data spread? Any outliers? Are the variables normally distributed? How are the relationships between variables, between dependent and independent variables? So graphical exploration, really complements descriptive statistics. So the basic idea of graphs in R: all graphs in R are displayed on a graphical device. If no device is open when the plotting command is called, a new one is opened and the image is displayed in it. Graphics device is simply a new window that displays the graphic. Graphic device can also be a file where the plot is written. So these are traditional graphic commands in R. I'm not expecting anybody to really memorize it. Most likely you'll probably end up using R Commander and you can just point and click and that's a lot easier. But just in case, if somebody does want to just use the R console and just do traditional R commands, and these are graphical parameters in R that you can use. And so let me just go ahead and show you. This is not an R Commander, but I'm going to basically draw a scatter plot. So this is just an example, and you can try it out as well later on. But I'm going to generate some data. And so if you see here, there's 3 bullet points under generate some data, and I'm just going to enter it into R. Okay, so now I'm in R, and I'm going to give you an example of how to draw a scatter plot just in the R console. So this is not in R Commander. What I'm doing here is that where you see this red line, I'm going to enter in, I'm basically just going to generate some data. And what I'm going to do is I'm going to enter in the x-axis here, and I'm just going to make this up, and let's see, for the y, we're going to do this. And so I know these commands, and they're written on the slide, so you can try this afterwards, but I'm just trying to show you how to graph in R. So you need to have these commands memorized in order for you to just create this. This is just, I'm just going to do this. And now I entered my data, and now what I am going to do is I'm going to plot this. and this is to create a scatter plot. And if you go back to the slide I showed you earlier, for the traditional command prompts of graphs, you can see that. And now I'm just going to hit enter, and here is my scatter plot, okay? And so the next thing, what I'm going to do is I want to add titles on the axis labels. So what I'm going to do is I am going to go back to my command prompt right here on the left hand side, and I am going to type in plot parentheses x y space main equals horses and hounds. As you can see, it has horses and hounds, races, and performance. And now the next thing what we want to do is we want to go ahead and do coloring spots according to the group, whether it's a horse or a hound. So what I'm going to do is I'm going to enter here in my command prompt the colors, right? So let's see. And again, like I've shared the different codes that you can use. Basically, it's like a cheat sheet. But again, if you're using R Commander, you do not have to use these codes. It makes it a lot easier than having to memorize this. And again, remember, it is, you have to be careful about spelling errors, upper and lower cases, which is why you see me putting in upper cases for the colors. And then I'm going to go ahead and the plot, I'm going to do X and Y on the main, which equals, let's see, right, okay. Let's see. And now you're going to see the different colors for horses and hounds on the right hand side. You see it changed colors. So again, this is another way to do scatter plots. So you guys basically get the point of how you work in R console with the command prompt. So what I just did was I entered in this code, or what they call as R language or command prompts, to get me a scatter plot. But you can do this a lot simpler in R Commander. So I'm not going to go and enter the rest of these plots. You can try these command prompts out, and you can, but it is possible if you put in these, then you can go ahead and change the plotting symbols. And this might be something that you might be interested in as part of your data in case you need to do this command. This is how you would do it. Drawing back to the scatter plot, you can save this by going to menu, file, save as, JPEG, or you know, as a BMP, PDF. And so this is how you save it, and the different image sizes, you can adjust that in R. Now, I want to go back, and I think in the beginning, like I said, I kind of compared R and R Commander, you know, to a car. They both get you to the same destination, but how you drive it is totally different. So R console is like a manual car. You need to know the different gears. While R Commander is kind of like an automatic car. You don't need to remember what gear you are in. So in R console, you have to know the language, the codes, and commands. And that takes time, dedication, and practice to be able to do it. It can be done, but for the purposes of this class and to save you time, you should really use R Commander. And now we're going to go ahead and get started. Before we get started in R Commander, remember you have to download R and then open up the R Commander package within R to access R Commander. So, okay, I'm going to walk you through these steps. Okay, so the first thing you want to do is go to r-project.org, and in this first paragraph it says to download R, so just click on that. And you want to click on this first one on the left hand side that says Zero Cloud. Just click on this link. And what it does is it brings you up to this download and install R. And so you have an option of Linux, Mac, or Windows. I am using a Windows PC, so I am going to go ahead and click Download R for Windows. And if you're using R for Windows, you want to click on Base. I just want to say if you're using Mac, your options might be different, but just go ahead and install it. And if for any reason, if the pages don't look similar, it's obviously because we're using Windows and you might be using Mac, but I don't think they have an option for Base and all these other things under Mac. But if you're using R for Windows and you're downloading, make sure you click on Base. When you click on that, it brings you to this screen, and you just want to click here on Download R 3.6.3 for Windows. But before you do, just kind of make sure, I don't know if you are aware your operating system, if it's 32 or 64-bit. The one I'm using is 64-bit, so I'll download the 64-bit version. So I'm just going to hit download R right here. And I'm using Google Chrome, so R will go ahead and download right down here. And so it's saying it's going to take 3 minutes. Now it's saying it's going to take 2 minutes. So we're just going to wait till it downloads. And then we can go ahead and click on this so it opens up the installer. Okay, so it's finally downloaded. And I'm just going to go down here. And I'm just going to click on this exe file. This is basically the installer for R console. And it's just loading. And it asks you, do you want to allow this app to make changes for your device? And you're just going to click on yes. And then it's going to ask you, select the language to use during this installation. And you're just going to click on English is fine. So you're going to hit OK. And then you're going to hit next. And then it asks you where you want to go ahead and download the program. So I'm going to just go ahead and put in the program files and hit next. And I know that my computer is 64-bit, so I'm just going to uncheck the 32-bit files because I don't need it. So if you have a 32-bit computer, then don't click on 64-bit files. But everything else should be fine, and you just want to hit next. And now it says, please specify yes or no on startup options. I'm just going to accept the default, so I'm going to hit no because I don't want this to start up every time I turn on my machine. Hold on. And here it says select start menu folder, and it's just going to be under R. And here it says select additional tasks. I usually like to have my software that I usually use on my desktop. It's just easy for me to access, so I'm just going to hit create a desktop shortcut, so once it's downloaded I can actually just find it on my desktop and launch it. So let me go ahead and hit next, and now it's just going to basically put the software onto your computer, and once this process is done, we can finally open R. Okay, so once it's finished downloading, this window pops up and you just click on Finish. And so, if you notice, R is now on my desktop on the left-hand side over here, because I created that shortcut to desktop. because I wanted it to be easily accessible to me. So now what I'm going to do is I'm going to double click on R, and here it is. It's open. Now, again, earlier you saw me entering different prompts. I am going to show you the easiest way to use R to get your data loaded and analyzed. So for that, we need R Commander. And so that's a package. And if you go up here, you can see load a package, and you can literally go ahead and see all of the different packages. And R Commander is actually in here, but you just have to find it. But I am not going to use this method of opening R Commander. I'll show you the easiest way instead of searching for it, even though it's right here. But I am going to show you the easiest way to open R Commander. So right here in your command prompt, you are going to type in library, but make sure it's lowercase. And then you're going to put parentheses, quotation, and capital R, lowercase c, m, d, r, quotation, and then close parentheses. And what you're going to do is you're going to press enter or return depending on your keyboard. And it's going to load up our Commander for us. Okay, so here we are in R Commander. And here it has opened the R Commander window. So what I like to do is, once this is opened, is to minimize R itself, so it doesn't get in the way. Just kind of put it over to the side. And R Commander is the main window. It is useful to still have R open, and you can just minimize it like I did in case it's distracting. But some things get printed in that R window, so you got to keep it around. You can play with this size of this. You can make it bigger and smaller, but you can't resize these two text boxes, which would be nice. But you can definitely resize this entire window here like this. Okay, so up here you have a script window, and below the script window you have the output window, and then below the output window you have a messages window down here. This will tell you various things, including errors. So if you get an error, this is where that shows up. And it has similar what you're used to, various boxes across the top with pull down menus. So you have the file menu where you can open script, save script. You can save output, you can exit the program through here from Commander. You can exit both from Commander and R. Or you could just use the X right here to exit. There is the edit box, which has like the basic edit functions. And here is the data pull down menu. Some certainly useful things here. You can import data from various packages, from a text file, SPSS, SAS, Minitab, Stata, or just an Excel file. Most likely your data will probably come from an Excel file, so this is very useful. There are also data sets in various R packages, so this can be pretty useful, and we'll be using this to read data sets from an attached package. So we have something that is ready to go, somebody has already created it, and we can just use this as an example for our data analysis. And okay, so over here we have active data set. Right now it's grayed out, but once you load your data, these will actually turn black, and you can actually use this, and this is actually very helpful and useful to do analysis with. And you can also manage variables in the active data set. But again, once the data is loaded, you'll be able to actually use these options. So just so we don't have to look at everything in gray, let's go ahead and load a data set. So we're going to go to Data and Packages, and we're going to go down here to Read Data Set from an attached package. But you have to have the package you want installed and loaded in order to get the data set you want. So if you click on this now, there are only 3 packages that come with the base model of R that are going to give us possible data set. That's car, datasets, and sandwich. And if you click on, for example, car data, double click on it, these are all the available data sets that you can use. And within each of those, you can see data sets right here. They have stuff on air passengers and different type of surveys, data sets here. But the demonstration that I want to do today, that data set is actually not included here yet. So let's go ahead and cancel this for now. Go back to our basic R window, open it up, go to Packages, scroll down to Install Packages, and once that opens, you will see mirror sites, and you just want to click on the first one and hit OK. Now you go, now Packages opens. Now you're going to have to go in Packages and find HSAUR2. So let's just scroll down here and find that package where my data set that I want to use for an example. And sometimes this can be tedious, but here it is. If you see, it's HSAUR2. So once this is highlighted, you just hit OK, and then it begins to install that package. Alright, and it doesn't take very long. As you can see, it has now downloaded that package. Now, how do you load that package? Well, there's 2 ways to do it, and you only have to, once the package is installed, you don't have to keep installing it again. So what you do is you go up here to Packages, you go to Load Package, and then you scroll down and find HSAUR2, which is right here highlighted. Just hit OK, and it's loading the required package tools. Over here it says loading, and if you see this, it's actually finished and it's done, so it doesn't really take that long. So this is one way to load a package, and it's probably the easiest, I think. Or you could do it this way. If you go ahead and open up R Commander again, you can go ahead and write in this script, our script area, type in library, open parentheses, capital H, capital SAUR, and the number 2, and close parentheses. And one thing again to remember about R is that it distinguishes between upper and lower case. So if we had lowercase here, it wouldn't be able to find that package. So this is the shorthand for load the package named HSAUR2. So once we do that, we can just go ahead and click the Submit button. It just puts the same output down here in the output window, just to say, yeah, I went ahead and loaded it. I am also just going to go ahead and minimize this and then just open up this so you're not distracted. So now that we have HSAUR2 loaded, we can now go back to Data and go back to Data and Packages and read data set from an attached package. Go ahead and click on this. And now you can see that HSAUR2 shows up under the different data sets in this column. So all of the possibility of data set packages are included here, and now earlier we just had 3, but now we have 4 since we loaded this package. So we're just going to go ahead and highlight age sour 2 and double click on it. And these are the data sets that are contained within this package. And these are great to use as examples for data analysis. Usually they're already cleaned up and it's easy to give you a demonstration of our commander using this. And the one we're going to go ahead and use is called school days. So we're just going to scroll down and it's in alphabetical order, and here it is. It's called school days. So one thing that is very useful is this button down here that says help on selected data set. So when we start using a data set and you want to familiarize yourself with the variables in them, if you just click on this help on selected data set button, you get a window that opens up and it explains the data set. So the description of the data set, data from a sociological study, the number of days absent from school is the response variable, and here you see the format, which is a data frame with 154 observations of the following 5 variables. I want to go ahead and mention data frame is the most common data structure in R. So most data sets we look at will be data frames. A data frame is simply a table with a two-dimensional structure where the rows are cases and the columns are variables. What is useful about a data frame is that the variables can be of different types, meaning you can have numeric variables where you have decimal points, you can have integer variables where you can have whole numbers, you can have a factor if things are in different categories. For example, high, medium, or low. There are a lot of different types of variables, but in a single data frame, you can have different types of variables, which is why it is so useful. And so here, we have the different variables within this data frame. So race, which is actually a factor, gender, again, this is a factor, school, also a factor, where it has the different levels, primary, first, second, learner, this is also a factor, and absent, which is number of days absent from a school, and I think this is an integer. You either are there or you're not there. I don't think they do half days. This gives you a basic idea what variables are like within a data set. So we can go ahead and just close this window, and we still have this waiting in the background, and if we decide this is the data set that we want to use, we will just go ahead and click OK. And now what you see here is the active data set. It says right here data set, and it says school days. So we can also go ahead and go over here and view the data set, which can be really useful. So just click this, and it shows up here on the right hand side, and I'm just going to pull it over here. You can go ahead and just see that all of our variables are right here, and the cases, so the variables are here in the columns, and then all of the cases are here, and we have, you can notice, we have 154, just like the description in the data set told us, and we have 1, 2, 3, 4, 5 columns, just like in that information window we looked at previously. And so if you don't want to count it just like how I just did, if you look down here in the messages window in our commander, it says the dataset school days has 154 rows and 5 columns. And let me click on view dataset again and bring it back. So that's another way to see if your entire dataset was actually loaded. So if you have your own data, obviously this messages box lets you know how many rows and columns were actually loaded. So you would want to know how large is your data set before you load it, and you just want to confirm down here that everything was actually loaded in correctly. And you really don't need the data open to do any type of analysis. You can just go ahead and close it. you've already told R what data set you're working with, and so R automatically knows just to pull from that data when it does its analysis. So notice that since we've been doing stuff in our commander, things have automatically started showing up in the script window and in the output window. So R is automatically going to enter into the script window whatever you've done from the pull down menus. So now that we have a loaded data set, if we go back up here to data and we go to active data set, all of these things that were grayed out before can actually now be used. So most of the grayed out ones are now black, but except this one, which is stacked variables and active data set. So one thing that's really nice about R is that it will only allow you to access menus and features that correspond to the data that you have loaded. So with this data set, we cannot stack variables. So it doesn't even give you that option. So we can do a lot of other things. So if you have multiple data sets you're looking at, you can change the active data set. You can go ahead and create a subset of the data. If you only want to look at some parts of the data, not the whole data set, you can also remove cases with missing data. You can save. So if you create something new, you can go ahead and save that data or export it. That can be pretty useful so you don't have to recreate it. And let's go back up here, and if you go to manage variables in active data set, this can also be very useful. So you can recode variables, if you click this, into different things. You can compute new variables, standardized variables. That might be something that you want to make into z-scores. So let's go ahead and do that. And again, the nice thing about R, it's only going to give you the variable that works for what you want to do. So the only variable that we can standardize is absent, because that is the only numerical variable that we have. All of our other variables were factors. You can't standardize a factor. So this is the only option. And if we had more, we could pick one, or we could have actually picked other ones, but since we only have a choice for this one. But I just want to point out, you could actually standardize all of your variables if you had more that showed up in this box. So if we click OK, here is what it just did. So it created a new variable, .z, and this is equivalent to an equal sign. But mostly in our script, you'll see this less than sign and hyphen right next to each other. And then scale would be the command. And it uses a school days data set. And it uses the absent variable. And then it makes this .z, puts that into a new variable, z.absent. So now, I know in R, when you do things, it sometimes looks like it didn't do anything. But if you go back into view dataset, you will see that up here in the absent, it has z.absent, and it actually changed the data set. So essentially what it did was it created a new variable. So these are the z-scores that correspond with the absent variable. So this can be a pretty useful tool. So you can also go back up here to data and go down to manage variables in active data set. And you can also convert numeric variables to factors. So if we wanted to make absent days high, medium, and low, we could do that through this, which could be similar to binning the numeric variable. There's a lot of different things we can actually do in here. And I also want to show you, if you go up here to statistics, there's a lot of things you can do. You can go here into summaries, and what you can do is just click on the active data set, and it pulls up a summary of the data set right here. Automatically give you summary statistics for every variable in your data set, but those summary statistics are going to depend on the type of variable. Since race is a factor, it just gives you a frequency count. 74 Aboriginal and 80 non-Aboriginal students. So these other variables were also factors, so it just gives you a frequency count. But for absent, it gives you actually descriptive statistics here, because now you have a numeric variable. And same thing for the z-score. So you have a minimum, you have a median, mean, you have a first quartile, third quartile, and the maximum. So this gives you a basic idea for every variable in your data set. So other options under summaries, you can get numeric summaries, frequency distributions. You can come back here and look at contingency tables, means. This is where you can get your different t-tests, different variances. There's non-parametric tests, and then there's fit models, linear modeling, linear. This is also where you would find your linear regression and other models. Also, the graphing features is one of the things a lot of people like about R. You have plenty of options to create graphs. It has pretty good graphing possibilities. So lots of things you can do here. Box plots, scatter plots, histograms, bar graphs, pie charts. So in graphs, let's just go ahead and do a scatter plot. This is only just to show you, but we only have two numeric variables, so it won't let us use a factor for one of our variables. So this isn't going to be a very informative scatter plot. So let me go ahead and also show you have options to do modeling, which I don't use that much, but you might be interested in using that. There's also different distributions you can create, normal distribution, t-distribution, and probabilities. You can load more packages, and the help is obviously really useful if you're just getting started and you need help. This is also an option here. I also want to show like the edit data set right up here. You can click on it, and yes, you can add a row, you can add a column, you can add, let's say you forgot a variable, you can go ahead and actually enter it in, right? But my suggestion is that you don't actually enter your data or don't create data frames in here. The best thing to do is just use an Excel sheet and edit in there and just import it. It's a lot easier. Even though you can add rows, you can add columns. If you just need to add one really quickly, but I would just keep one data set. I'm just going to click discard edits. Yes, yes. Okay, so essentially, this is basically R Commander. You can do graphs, you can do statistics with your data set, but let me also go ahead and share how can you import your Excel file. So I would suggest saving it as a comma separated value file, a CSV, and it's a lot easy. So in this YouTube video description, if you go into the description, you can actually download the school days dataset as a CSV file. So what I'm going to do right now is I'm actually going to import the CSV file into my R Commander. So to open up a CSV file, just go under the data drop down, go to import data, and I'm just going to do from text file clipboard this very first one right here. And local file system, because I have it saved in my downloads folder, and the field separator is commas, and that's fine. It says a period, and I'm going to enter this as my own data instead of calling it just data. You can name it whatever you'd like, and just hit OK. And now I'm going to find the schooldays.csv because I went ahead and downloaded it. And I'm just going to click open. And now if you see, the active data set is my own data, which I named, but it's actually just the school days data as CSV. Now what I want to show you is that's how you import your own CSV file. And so the data set, my own data, which I titled it, has 154 rows and 6 columns. And if you view the data set, obviously it's the same data set, it's the school days data set. But this is how you can import your own CSV file into our Commander. And then you can obviously run your statistics, your graphs, and so this is basically a really quick way to do data analysis using R and R Commander. I hope it was helpful, but just in case, if you need more help with R, these are some really good R resources that you can find in the PowerPoint, so feel free to look through these. You can go ahead and contact me at hamad.khan@uta.edu if you have any questions related to this presentation, or if you have questions about R and R Commander. For all other data related inquiries, you can email datacave@uta.edu, and essentially it has a lot of our data team members, data librarians that can help you with your data related issues. We try to help researchers throughout the research data lifecycle, help them manage their data, and then obviously archive it into a data repository. So if you have any questions, please feel free to contact me or the Data Cave. And I just want to thank you for watching this presentation.